Hello everybody, welcome back. Now in this lecture we'll talk about the minerals and how they are formed and where they are formed, okay. And the study of mineral, the branch in geology is termed as mineralogy. So as we discussed in the previous lecture, the different type of plate boundaries. So most of the minerals, okay, are formed along the plate boundaries, and that is mostly along the subduction zones where we have the source of magma coming on the surface, okay. So if we broadly we look at the major locations where the magma comes out from the volcanoes, okay, are the subduction zones, okay. Either they are that subduction zone is between the continental and oceanic plate, or oceanic plate, okay, and or we are having the spreading centers. So these are the three major areas where we can look at and try to look at the magma which is coming out on the surface, okay. So again, just to quickly look at that, what are the sources. So as I have explained, so we have the oceanic subductions, we are having oceanic continental subductions. These are the locations where we will have the source of magma coming right up to the surface, okay. Now in total, if we look at the definition of mineral from different sources, what it says is that a mineral is a naturally occurring homogeneous solid inorganically formed with a definite chemical composition and an ordered atomic structure, okay. So each mineral will have a typical chemical composition and a atomic structure, and this is very important. We will study how we can identify based on the atomic structures also the different minerals and the chemical composition. Another definition says, which was been given by Dana and Ford in 1932, that a mineral is a body produced by the processes of inorganic nature, having usually a definite chemical composition, and if formed under a favorable condition, a certain characteristic atomic structure is expressed in its crystalline form, okay. So we will look at the crystal structures also, that are what different, and the crystal forms also. So these are the crystalline forms and other physical properties, okay. That is what been given, again almost similar, talking about the inorganically formed and having definite chemical composition and the atomic structure, okay. Then third, it came in 1990, it says minerals are naturally occurring inorganic substance with definite and predictable chemical composition and physical properties, okay. And then it talks about that finally, if we take considering all these definitions, we can say that a mineral is a natural inorganic homogeneous solid substance having definite chemical composition and regular atomic structure, okay. So for example, this is some of the pictures which have been shown of diamond, and then we are having ruby, and then we are having the quartz, okay. So this suggests that the mineral must have formed naturally under natural conditions and not artificially. So of course in the market we have some artificial stones which are also mimic the similar structures and all that, but they are not the real one, okay. Like for example, the artificial diamonds which we call the American diamonds, rubies, sapphires or emerald, etc., this cannot be considered if they are artificially formed crystals, okay. So diamond is the hardest one, okay, amongst the all, having the hardness of around 10. So we will talk about this when we are talking about the hardness scale and all that. And then we are having ruby, which is also like in Sanskrit it is known as Rajratan, which is again and very important mineral in terms of the gemstone, okay, or it is a gem variety and variety of corundum. And then we are having the sapphire, which is again a transparent or non-red variety of corundum, okay. Of course, other than that, what we are having, we talk about the fuel minerals. So we have the coal, petroleum, natural gases, etc., are organic substances, okay, which to strict sense are not minerals as per the definition. However, they are considered as a mineral and we call them as a fuel minerals, okay. So coming to that part which we are talking about the crystalline forms, So, what is crystal? What has been defined as? It is again a Greek word called crystallos. The Roman, as they said Romans, they said crystallum. Okay. So, the word crystal can be applied to a solid substance that grows with a planar surfaces, okay, or a naturally occurring solid body bounded by a smooth and plane surface arranged in a geometric pattern. So, it has an angle in between the two planes, and you will see that most of the minerals are having very definite crystal forms, okay, and the crystal planes. This is another an outer expression of the internal atomic structure. Okay. So, if you are having the internal atomic structure, this is for the quartz and all that, where you are having silicon and on oxygen. So, if you are having a definite internal structures will be reflected in the form of the crystal face and crystal surface. Okay. So, this is an example of quartz, which is a hexagonal prism, okay, which is definitely like a very beautiful crystal faces you can see here, okay, very definite at definite angle, like here. And then another example is of the halite, which is in the cubic form. So, you see almost all faces are at right angle. Okay. So, if you define the crystal face, the plane surface that bounds the crystal is called crystal face, and the geometric arrangement of the crystal faces is termed as the crystal forms. Okay. So, these are the crystal forms we are having: isometric and hexagonal system and all that. So, we will talk about this in due course. So, these are all the crystal face. Okay. There are different minerals which are not having a definite crystal face, and they are termed as mineraloids. Okay. Some naturally occurring minerals, solid compounds, do not meet the definition of minerals because they lack one in definite composition or a characteristic crystal structure or both, okay, and they are termed as mineraloids. Okay. So, example is opal, which is amorphous, okay, it is very soft in nature. And then we are having polymorphs. Okay. So, we have crystalline minerals, we have mineraloids, okay, and then we are having polymorphs. Now, polymers are the minerals having same chemical composition but different crystal structures. So, this is an example which talks about the calcite, okay, and having hexagonal crystal form, and then we are having aragonite, which is orthorhombic in nature, okay, but both are having same chemical composition. So, the polymers are those minerals having same chemical composition and different crystal structures. Now, conditions for the formation of crystals, okay, again slow cooling of magma, and then free surroundings that facilitate the crystal growth in different direction, and third is no interaction or no interference of the adjacent or nearby growing minerals during the solidification. So, these are the conditions for the formation of the crystals. Okay. Now, mode of formation of minerals, if you take in total what we are having, there are three modes, okay, of mineral formation: by cooling of magma, by secondary processes, that is what we are talking about, that if they are having a chemical process and all that, okay, and third is the under metamorphism. So, under great temperature and pressure beneath the earth surface will result into the change in the or alteration of the one mineral to another one. Okay. So, mode of formation of minerals. So, that was the mode of formation of minerals we are talking about in terms of the cooling of magma, secondary process, and under metamorphic. Now, here mode of formation of minerals, if we take, okay, most of the minerals are formed at different stages of cooling of magma. Okay. So, as the magma is erupted on the surface, it cools down, it solidifies. So, that is the process along which the different minerals will form, and we will see that reaction series how the different minerals are formed. And almost 90% of rock forming minerals like feldspar, quartz, amphiboles, mica, olivine, okay, are formed along during that process of cooling of magma. Also, some precious minerals, jamestones like garnet, topaz, beryl, beryllium, etc., are formed during the cooling of magma, and that process is termed as magmatic crystallization. Secondary processes, if you take, is weathering, precipitation, or deposition. Okay. leads to the formation of minerals like calcites, dolomite, bauxite, salt, coal, petroleum, and this is because of the mainly because of the weathering. Okay. And then we are having more of clay minerals like kaolinite, stalactite, montmorillonite, agate, etc. Okay, are the reasons for the how they are formed in the secondary processes. Okay. Then finally, we are having third one is the metamorphism of the minerals that are formed. So, under the influence of high temperature and pressure, with and without involvement of the chemical active solution, we see the example for the formation of different minerals or alteration of the minerals from one to another. Okay. So, we see andalusite, sillimanite, kyanite, sterolite and all that. Okay. And the major locations, as we have already discussed, I will just move ahead. Okay. So, important rock forming minerals if we take, okay. So, what we are having, more than 75% of the earth's crust is made up of elements like oxygen and silicon. Okay. And in order of abundance, if we take, silicates are the most abundant rock forming minerals, followed by oxides, carbonates, phosphates and sulfates. Okay. So, we are having silicates are the minerals which comprises silicate tetrahedron or silicate anions, and the examples of these minerals are commonly seen, which are feldspar, pyroxenes, amphibole, olivine, garnet, quartz, clay and mica. And whereas if we look at the non-silicate minerals, we are having oxides, okay, mainly the hematite, magnetite, and then we are having sulfides, which we are having chalcopyrite, which is rich in copper, or we are having lead, that is galena, and then we are having carbonates, mostly the calcite, we are having sulfates, we are having gypsum, and then phosphates, we are having apatite. Okay. So, these are the non-silicate minerals and we are having silicate minerals, and silicate minerals are most abundant in nature. Okay. Now, coming to the feldspar particularly, this is the form of the silicate minerals. Okay. We have again different type of feldspar, and mostly what we have is the plagioclase feldspar, and we are having orthoclase feldspar. Okay. So, what we see the potash feldspar mainly, okay. And then further plagioclase feldspars are been divided into three, which starts from sodium and we are having right up to the calcium. Okay. So, we are having the albite, we are having labradorite and we are having anorthite. Okay. And labradorite is one of the mineral which has also been used by many people as a gem variety, which has the characteristic of play of colors, and this has been termed as labradorescence. Okay. So, labradorite is known for its displaying different colors. Okay. And this phenomena is very much commonly seen in the plagioclase feldspar. Then we have other minerals like orthoclase, microcline. This is again the potash feldspar we are talking about, and then we are having albite and this is the plagioclase part. Okay. So, this is how it looks like in a hand specimen. Okay. Then we are having anorthite and we are having again pyroxenes. Okay. So, mainly these are the pyroxenes are rich in mafic, is magnesium and iron, and another one you are having, this is agate and then this is jadeite also, this is aluminum silicate minerals. Okay. And then we are having amphiboles, again rich in magnesium. Okay. We are having hornblendes. Now, these all minerals are been seen in different type of rocks, and based on the composition different type of rocks are also been classified. We will see when we are talking about the rocks and all that. Okay. And then we are having olivine, which is again rich in magnesium and iron, and we are having mica, which is again silica and magnesium and iron we see. Okay. So, this is termed as muscovite, and then we are having biotite. Biotite is but darker in color because of the magnesium and iron, whereas this is lighter because of the silica and aluminum. Okay. So, these are also one of the characteristics parameter which we are using while identifying the mafic rock and felsic rock, or the rocks which are rich in silica and all that. Okay. They will be lighter as compared to others. So, they are having these are the darker ones where we are having magnesium and iron. Then we are having quartz, mostly the silica, silicon oxide we are having. So, we have the crystal structures which are very definite. This is a rock crystal, and this is what we see is the pink variety of quartz. Then we are having the we have discussed a little bit about the non-silicate minerals, mostly are formed because of the precipitation or the solution activities. We have halite, we have galena, we have pyrite, calcite, etc. Okay. Now, in 1922, Bowen identified two series of mineral forming formations, okay, or the process of crystallization of the minerals. He suggested that the minerals crystallize in a particular manner, okay, with a varying temperature which is ranging from 14,000 degrees to 800 degrees. Okay. So, that is when the magma comes out, it is extremely hot and it slowly cools down. So, in this process of cooling down, different minerals will crystallize, okay, and different crystal forms will be seen. Okay. So, he identified and suggested two series. One is discontinuous series, okay, where mineral crystallize in sequence with decreasing temperature, mainly ferromagnesium minerals, example olivine, pyroxene, amphipole and biotite. And then if one mineral becomes chemically unstable, another mineral begins to form, okay, and that continues in the form of the cooling process also. Okay. And another was the continuous series. Okay. Now, here plagioclase feldspar forms with a chemical composition that evolves from calcium to sodium rich minerals, okay, which with decreasing temperature. So, one is the continuous, another is discontinuous series he identified. Now, if you look at the Bowen reaction series, what it shows, okay, discontinuous series and continuous series with different type of minerals forms in the process where we are looking at the decrease in temperature. Okay. So, we have mafic minerals, we have minerals what we are rich in feldspar, okay, that is ferromagnesium minerals and non-ferromagnesium minerals we are having. So, mostly olivine, ferromagnesium mineral, then goes with the pyroxene. This is how the stages are there where different type of minerals will form. So, first olivine will come, then pyroxene will form, then we are having the amphiboles, and then we are having the biotite. Okay. These are all the part of the discontinuous series and which are rich in ferromagnesium minerals. Okay. And then finally, what we see in the continuous one, we are having calc plagioclase, anorthite, then we are having labradorite, which has sodium calcium both, and then we are having the sodium plagioclase, that is an albite. Okay. And then finally, what we see out of both the series is the potash feldspar, okay, and we are having finally the formation of muscovite and quartz. Okay. So, this all happens with the decreasing in temperature from 1400 degrees to 800 degrees, okay, or further. So, this is this you can remember and try to understand that how different discontinuous and the continuous series leads to the formation of minerals with respect to the decrease in temperature from 1400 to 800 degrees. Okay. And this was been given by Bowen, and this series has been termed as Bowen reaction series, comprising discontinuous and continuous series, okay, of ferromagnesium and magnesium non-ferromagnesium minerals. Okay. Now, criteria for identifying minerals. This is again a very important aspect which we should know, and we can use this criteria while in the field also. One, where we can identify the different minerals based on the understanding that what different properties the respective minerals will have. Okay. So, crystal systems, one is the first is the crystal. So, we look at the crystal system and we try to identify or classify the different minerals. Okay. So, most of the mineral occur in nature are having crystalline forms, okay, which is a reflection of the internal atomic arrangement that we were talking about. Okay. So, this geometric arrangement of atom result into different shapes of crystals. Okay. So, for example, cubic, either it is prism or it is hexagonal or it is tetragonal. Okay. So, on the basis of the systems or symmetry of the crystal forms, these forms are subdivided into 6 different systems, okay, where we are having cubic, we have tetragonal, we have hexagonal, we have orthorhombic, monoclinic, triclinic. Okay. So, we are having 6 crystal system, and these are the axes, okay, which talks about that how they are, okay. All 3 are equal, and then angle between them are also almost at right angle, okay. And then tetragonal 2 are equal, 1 is unequal, and the angle is almost like 90 degree between them. Hexagonal 3 axes are equal in the same plane, and the third one, which is the larger one, axis, which is not equal to one another, and the angle also varies, where one most of them are having 90, but one is almost like 120 degrees with respect to other 3 and all that. Okay. So, similarly, other relationship of the axis is also given. So, based on this crystal system, you can also try to understand that the minerals. Okay. So, this again that has been given that how 6 crystallographic systems exist, and which can help, and these are different examples which are been given. For example, for cubic we are having halite, garnet, pyrite, fluorite. Hexagonal we are having quartz, calcite, hematite, and then so on, and then we are having triclinic, we are having plagioclase, feldspars, and kyanite. Okay. So, zircon is on the tetragonal, and mica what we see is the monoclinic system. Okay. So, these are the different crystals and the axes which have been shown here and the in this videos. So, isometric 3 axes, all of them are equal in length and lies at 90 degree from each other. Then we are having hexagonal 4 axes, where 3 axes are equal in length, lies in the same plane as you see here, and then of 120 degrees from each other, and the fourth one is either longer or shorter. This one is either longer or shorter, and it will be at right angle towards the other corners. Okay. Then we are having the tetragonal 3 axes, 2 are equal in length, 1 is unequal, all 3 are at right angle to each other. Then we are having orthorhombic 3 axes, okay, all 3 unequal in length, all 3 axes are at right angle to each other. Okay. Then we are having monoclinic 3 axes, all of them are unequal in length, 2 of them are right angle to each other, while the third one is having greater than 90 degree of angle. Okay. And then we are having triclinic, all 3 axes of them are unequal in length, none of them are at right angle to each other. Okay. Then we come to the other part, is this a simpler term used to describe the cleavage. Okay. So, we can have cleavage, either it is perfect, okay, either it is imperfect, good, distinct. These are the terms which have been used to identify or pinpoint the different type of cleavage in the minerals, and we can say also either it is distinct, indistinct, or poor cleavage. Okay. Now, cleavage is said to be basal when it occurs perpendicular to the major axis of the minerals, and prismatic when it occurs parallel to the major axis. Okay. So, this will be the crystallographic axis which we are talking about. Multiple cleavage that produces geometry, either it is polygons, are referred as octahedral cleavage in the minerals of, like example is fluorite, and cubic cleavage, and like example in halite, and we are having rhombohedral in terms of calcite, and we are having one set of cleavage which has been seen in mica, chlorite, and talc. Okay. 2 set mostly in the feldspar, pyroxene, and amphibose. Okay. So, this is another property which is very much important to identify or differentiate one mineral from the another one, apart from the crystal shape and crystal form. Okay. And then we are having calcite, galena, we will have 3 sets of cleavage. Okay. So, the cleavage is the plane along which the mineral will break actually. Okay. And then we are having fluorite, we are having 4 sets. Okay. So, thank you very much, we will continue in the next lecture.